All right, we are given the mass of a sample of a diatomic gas. So we have mass. If we know the molar mass, we can get moles. All right, we're also given volume, pressure, and temperature. So this is going to require the ideal gas law, PV equals nRT. So identify the gas. Well, we're going to need the number of moles. Does it give us pressure? Yes. Does it give us volume? Yes. Does it give us temperature? Yes. All right, it's giving us everything but moles. So we got to figure out moles. All right, moles is N, represented by N. Let's divide through by R and T, and we're going to get pressure times volume over the gas constant R times T. All right. Oh, before we go on, let's change that Celsius to Kelvin. So we can add 273.15 to it, and it's going to be 318.15 Kelvin. Got to use an absolute scale on these gas laws. All right, so now we can plug and play. Pressure, 1 atmosphere, 1.00 atm, and volume is 3.00 liters. All right, so just got to check these units that there's a gas constant that matches them. So, like if it wasn't liters, we would probably have to convert to liters. Now, R, we're going to have to use the universal gas constant that has atmospheres in it, because that's, unless you want to convert atmospheres to something else. All right, so let's use 0.08206 atm liters over Kelvin mole. All right, and the temperature is 318.15 Kelvin. Okay, let's cancel some of these units out. Liters, liters, atmospheres, atmospheres, Kelvin, Kelvin, they're all gone. And we're left with moles when we're done calculating. 1 times 3 is 3, divided by 0.08206 divided by 318.15. All right, so the number of moles, we'll just keep that stored in our calculator, is 0.115 moles of this gas. Now we can get the molar mass. Molar mass is grams per mole, so we'll just put the grams given right above it, 4.37 grams. Now we can't leave our answer like this. That's we gotta simplify that. So 4.37 divided by that number that was stored in our calculator earlier, the 0.1149 number, 38. So the molar mass is 38.0 grams per mole. All right, we're not asked to find that molar mass. We are asked to identify this gas. Now, it can be many different gases with that molar mass, but it tells us it's a diatomic gas. So diatomic means there's 2 of them. So if you divide that by 2, that's 19, right? Yeah, okay, so 19 grams per mole is the monatomic version. So that would be fluorine. Fluorine's got 9 protons and 10 neutrons. So this is going to be F2 is the diatomic gas. All right, so all right, let me do a better job explaining. All right, each fluorine has a molar mass of 19 grams per mole, or it's like 18.998 or something like that. And that's off the periodic table, by the way. And so there's 2 of them. All right, so this is the diatomic molar mass. So the answer is F, fluorine.